So this one is a lesson for the 6 rational equations in inequality. From the word rational, okay, you expect that all the givens will contain a rational expression. Rational means fractions, okay? So rational equations and inequality. So um, we will be discussing how to solve rational equations and inequality. So um, let's say, for example, number 1, solve for A. We have here A minus 5 over A is equal to 4. So whenever there are fractions, the first thing you have to do is to get rid of the denominator by multiplying all the terms by the least common denominator of the given. So here, the denominator of A is 1. The denominator of 4 is 1. Okay, this one is A. So this one, the LCD is simply A. Okay, the least common multiple of the denominator. So if you multiply this is A times A is, you have A squared minus A, and A times 5 divided by A is simply 5 because this A and A will cancel out. And you have to do also at the right side, multiply this by A. So 4 times A is, you have 4A. And then you arrange this one, okay, in standard form, ascending order, a descending order. So this becomes A squared, and then transpose 4A to the left, it becomes minus 4A. Minus 5 is equal to 0. And then you solve for A by factoring. This one is, you have A minus 5, right? And A plus 1. Because negative 5 times positive 1 is negative 5. Negative 5 plus 1 is negative 4A. And then solving for A is equal to 5. And here, A is equal to negative 1. Okay? So there are 2 values of A. One may be the real root, one may be the extraneous root, or both may be the real root. Meaning to say, if you plug in these numbers here, it has to be equal to the right side, which is 4. Now let's try 5. This is 5 minus 5 over 5. 5 over 5 is 1. So 5 minus 1, 5 minus 1 is equal to 4. Okay? Now let's try to use negative 1. If A is negative 1, negative 1 minus 5 divided by negative 1 is negative 5. Minus minus is positive 5. Negative 1 plus 5 is equal to 4. So both 5 and negative 1 are roots of this rational equation. Okay? Number 2. This one is 9 over B plus 5 equals 3 over B minus 3. So if you're going to multiply this by the least common multiple of the denominators, okay, the least common multiple of the denominators will be B plus 5 and B minus 3, okay? I just multiply this, okay? Because this is B plus 5 and then B minus 3. And then you're going to multiply the left side and the right side. So this is also B plus 5 and then B minus 3. So B plus 5, B minus 3 times 9 divided by this one, okay? Look, don't be confused. So B plus 5 and B plus 5 will cancel out. So what is left is simply 9 times B minus 3 is equal to, at the right side, B minus 3 and B minus 3 will cancel out. So what is left is 3 times B plus 5. Oh, now, distributive law. I'm going to distribute. This one is 9 times B minus 9 times 3 is 27 equals 3B plus 15. Okay, and then I'm going to um, transpose 3B to the left. This is minus 3B, so that one is 6B. Plus 27, plus 27, that one will give me 42. And then divide by 6, 42 divided by 6 is equal to 7. Okay? So if we want to check, this becomes 9 divided by B is 7. 7 plus 5 is 12 is equal to 3 over B is 7. 7 minus 3 is 4. Is 9 over 12 equal to 3/4? Okay, if you simplify 9 over 12, it is equal to 3/4. So the value of B is equal to 7. Okay? This one here is, there are 3 denominators, B plus 2, B plus 2, and then B plus 1. But the LCM is, you have B plus 1 and B plus 2. Okay? You multiply the right side also by B plus 2 and then B plus 1. So when we solve this one, okay, I'm going to leave this for the meantime, okay, and we will go back to the graded recitation for your graded recitation afterward. That is solving rational equations. Now let's try to solve one example for rational inequality. So let's do the first one. Rational inequality is something different from equations because we have to test our intervals if it is in fact a solution to the given inequality. So this one is, what I'm going to do is the same thing. I'm going to get rid of my denominators, okay? And so I can write everything at the left side. That will be minus 3/4 is greater than 0. And I will solve my A. Now, I will solve my A first, okay? Which will be the point wherein I will decide later on, okay, if I am going to get the right side or the left side of that point for my solution. I'm going to explain that afterwards, okay? So what you will do first is you're going to change the inequality symbol, this greater than symbol, into equal sign first, okay? The equal sign first to solve for A. So I am going to multiply this side by the LCM of the denominators, 3A, 6A, and 4. What number goes to 3? What number, okay, wherein 4, 6, and 3 goes into exactly, the LCM, okay, is 12. Because 3 goes to 12, 6 goes to 12, and 4 goes to 12, okay? And there is an A here, there is an A here, there's no A here, so we have to put A here also, okay? So 3A goes exactly to 12A, 6A goes exactly to 12A, and 4 goes exactly to 12A. It's just like this one a while ago, okay? We just multiply them, okay? We multiply them here, it should be 24, but the LCM, the least common multiple for 3, 6, and 4 is 12. So now I'm going to multiply all terms by 12a. So 12a times 2 is 24a divided by 3 is equal to 8. Okay? Or I can divide first. 12a divided by 3a is 4 times 2 is you have 8. Plus 12a divided by 6a is 2 times 5 is 10. If you don't want to divide first, you multiply first and then divide is the same. 12 times 5 is 60. Okay, divided by 5 is 10. A and A will cancel out. Minus, this one is 12A divided by 4 is 3A times 3 is 9A is equal to 0. Make that thing equal first. Okay, so solving for A, this one is negative 9A is equal to negative 18. So A,
Why does it turn to 0? I mean, equal to.
A is equal to positive 2. Okay, this is what I repeat, okay? Because we are solving for A first, okay? We're solving for A. That's why we change this one to equal sign. That's your first step, okay? And then to determine the solutions, okay, we're going to test values to the right and to the left of A, okay? So you will see afterwards why I put that, I changed that greater than to equal for the meantime, okay? So now A is equal to 2, okay? And then if you look at this, these are fractions. And so there is an exclusion here that A cannot be equal to, okay? So we can write there is as the exclusion. What is that number, the value of A that is excluded from this being a fraction? Meaning to say A cannot
0.
be equal to 0. Who said that?
Janelle.
Okay, Janelle, that's good. So A cannot be equal to 0, okay? Because it is a fraction. Okay, fraction, your denominator cannot be 0. Okay, so now the next thing you do is you're going to draw a number line, okay? And test these points. For A equals 2, okay? For A equals 2, and A cannot be 0. So it cannot be A. It cannot be 0, okay? That is why it's an open circle. Now, we're going to test these intervals. You call this one as the case method, interval method. We're going to test these intervals, okay? Wherein this one, the given inequality will fit. The given inequality is 2 over 3A plus 5 over 6A is greater than 3 over 4. Now, which one of this interval is the solution? Or two of this interval is the solution? Or it can be all of this interval is the solution. So what we're going to do is we're going to test these intervals, okay? So this one is A is equal to 2. Now, but we want this interval here. So this one, let's test A is greater than 2, meaning to say this interval here. So you're going to pick any number in this interval, A is greater than 2, and plug it in here and find out if it is greater than 3/4. So this will be 2 over 3 times what number do you want? Greater than 2. Let's say the smallest one is 3, right? So 2 over 3, okay? Plus 5 over 6 times 3, is that greater than 3/4? So this one is 2 over 9 plus 5 over 18, is it greater than 3/4? 3/4. Oh, is it greater than 3/4? 2/9 is
No,
actually
right?
4/18. It's 9/18 is 1/2, right? So this one is not true. Okay, not true. So this interval is not true. Okay, we cannot have x is greater than 2. Now let's test this one, this interval here. This interval is, that's the first possible. So this one is not a solution. Okay, let's test this interval here. How do we write this interval is for x is less than 2, but greater than 0. So any number here. So what is that number here? In between 0 and 2.
One.
Mr. Bika,
1. Okay?
Mr. Bika,
Yes.
would it be 0 is less than x and is greater than and equal to, or is it just
No. It's less than 2.
okay? But is it
Okay.
less than and equal,
Oh, wait a
or
minute.
just less than?
This one is to play safe. Okay, this one is play safe. To play safe, let's take 1 here. Okay, and let's decide afterward if 2 is also a number, since that one is a is equal to 2.
Okay.
Okay. Okay, that's why I did not put a circle here. You decide afterwards. So let's test 1. So if x is 1, this becomes 2/3 times 1 is 3, plus 5/6. Is that greater than 3/4? Is that greater than 3/4? This one is
Yes.
yes, right? So there you go. So this one is a possible interval. Okay, and then the last one is this one, less than 0. X is less than 0. So it is negative numbers, right? Negative numbers. So if this is negative, this one is 2 divided by -3. Let's say -1. We're taking -1 here. Plus 5/6 greater than 3/4. This is negative numbers, right? A negative number cannot be greater than a positive number. So this one is not a possible answer. Okay. So this one is only the solution. Okay. So you see now why I make this one equal to afterward, because this is our point. Okay. Where we decide to get the solution. Is it to the right or to the left of that point there? Now, let's try to check if 2 is also a solution. Okay, so if x is 2, this will be 2/6, right? If x is 2, okay, this will be a 2/6. That's 3 times 2 is 6. Plus 5/12. Is that greater than 3/4? Is that greater than 3/4? So this one is actually 4/12, right? 4/12. 2/6 is 4/12. 4 plus 5 is 9/12. It's not greater than 3/4. It's equal. Okay. So this one is less than. It cannot be 2, because if it is 2, oh, did you see that, Janil? It
Yeah.
cannot be
Yes.
2, because if it is equal to 2, then this side here is equal to that. Okay, so it has to be less than 2.
Couldn't we have
Yeah.
figured that out just by looking at the sign?
Huh?
Couldn't we have figured it out just by looking at the sign?
What do
Is
you
it-
mean by, what do you mean?
Because if 2 over 3a plus 5 over 6a were greater than or equal to 3 over 4, we would know that 2 was included. But since it's only greater than and not equal to, we know that 2 isn't included.
Yes, okay, there you go. Okay, and we solved in the first place a while ago that if A is equal to 2, then this is not greater than 3/4. Okay, it is equal. That's why 2 is not included. But we just take 2 here as our point, okay, a demarcation point where we decide to determine the solution. If it is to the left, to the right, to the left of 2 is the real solution. And we conclude also that this one is not a solution. So it's just in between 0 and 2. Okay? So there you go. If the given is like this, I will just direct you how to do this and you have to do it yourself. This one is in factored form. So the zeros are, what are the zeros of the numerator? The zeros are, you have, this one is x minus 2. So the 0 is positive 2. This one is positive 1. This one is positive 3 and positive 4. Those are the zeros. So 1, 2, 3, and 4. Now, which one is the solution? Will it be x is greater than 4? Okay, there are 4 possible solutions here. This one here is x is less than 1. B, this one is x is less than 2, greater than 1. C is in between 2 and 3. X is less than 3, greater than 2. And the last one, 5. This one is x is less than 4, greater than 3. And the last one is x is greater than 5. This one, greater than 4. Okay, so you test each of this by plugging in here the numbers. If it is less than 0, then the left side must be a negative. Okay? If it is less than 0, the left side must be negative. So let's try to test 1. Okay, let's test the first one. If x is less than 1. And then we're going to decide if this is a solution or not. And then these things will be yours to do. So if x is less than 1 here, it's a negative number. Let's say, no, 0. 0 is less than 1, right? So let's use 0 here. So this becomes x is 0 minus 1 divided by, times 0, that's 2. 0 minus 2, 0 minus 1 divided by 0 minus 3 and 0 minus 4. Is that less than 0? If it is less than 0, this must be negative. So 0 minus 2 is negative. 0 minus 1 is negative. Negative times negative is positive. Divided by, let's do the bottom. 0, this is raised to 2. It's raised to 2 there. So this one is 0 minus 3 is negative. 0 minus 4 is negative. Negative raised to 2 is positive. So negative times positive is negative. Okay? So here, if you divide positive divided by negative, will that be less than 0? Yes or no? Positive divided by negative. Positive divided by negative is negative, and negative is always less than 0. So this one is a yes. So x1 is a solution. Okay, and then continue testing for this one. In between 1 and 2, you can use 0.5. You can use 2.5, you can use 3.5, and you can use 5 here, okay? And decide the solution. Okay, so that is rational equations and inequalities.